Hello friends, I welcome you in lecture number 35 on basic statistics. In this lecture we are going to discuss alternate formula for coefficient of correlation. We will also show that coefficient of correlation is independent of change of origin and change of scale. So that we will discuss with the help of example. First we discuss what are the alternate formulas for coefficient of correlation. So far we were using this formula that coefficient of correlation between two variables x and y is given by sigma x minus x bar times y minus y bar divided by square root of sigma x minus x bar square times sigma y minus y bar square. So far we have used this formula to obtain coefficient of correlation. Now sometimes if this sample means x bar and y bar, if these means are not an integer or suppose they are fractional values, then these computations of all these values become tedious. So in that case we have another formula which we can obtain after simplifying the original formula of coefficient of correlation. So we will not discuss the derivation of this formula. We will just write down the alternate formula for coefficient of correlation. So that formula is given by n times sigma x into y minus sigma x times sigma y divided by square root of, here in the square root we have two terms in the product and we can remember those two terms in this way. In this numerator, suppose I replace y by x. So if I replace y by x, what I will obtain, that I am writing here. So here I keep n as it is. If I replace y by x, I will have sigma x square. Here if I replace y by x, I will have sigma x times sigma x. That is, I will obtain square of sigma x. This is the first term which will be in the product. Another term can be obtained by replacing x by y in this term. So that another term is written by replacing x by y here. So that is n times sigma y square minus square of sigma y. So this is another formula or alternate formula for coefficient of correlation, and it is not hard to remember this formula. Here we have to remember this numerator, it is n times sigma xy minus sigma x times sigma y, and these two we can write by replacing y by x in this numerator, and this we can write by replacing x by y in this term. So if x bar and y bar are not integers, sometimes this formula is helpful provided that we have small values for x and y. Now this formula is also not comfortable if we have large values for x and y. So in that case we will consider change of origin and change of scale. We will define new variables u and v using original variables. So we will define u equal to x minus a divided by h, v equal to y minus b divided by k, where a and b are assumed mean, or a is the value of x, a we will assume as any value of x, b will be any value of y, and this h and k will be the gap between values of x will be h and gap between values of y will be k. Now this h and k we will not have that gap common for values of x and y. Suppose I have this type of values for x, 100, 105, 110, 115, then I can say that h equal to 5. So if there is a common gap, then we will use this h. If gap is not common, then we will consider simply u equal to x minus a. Same thing for values of y. For example, if I have this type of values 95, then 92, then here there is no common gap between any two neighboring values of y. So in that case, we will not consider this u equal to x minus a over h. Instead of that, we will consider u equal to x minus a, and same thing for values of y. So coefficient of correlation is independent of this change of variables, or coefficient of correlation is independent of change of origin and change of scale. If we define new variables u and v in this way, and if we compute coefficient of correlation between these variables u and v, then it is exactly equal to coefficient of correlation between x and y. So if values of x and y are large, then we can use this method. We can change the variables to new variables, and we can find out correlation coefficient between new variables that will be exactly equal to coefficient of correlation between original variables. And this method is known as step deviation method, which we have used in computing mean also. So we can use this step deviation method in the case if values of x and y are very large, and if values of x and y are small, and if x bar and y bar are not integers, then we can use this formula to compute coefficient of correlation. If x bar and y bar are integers, and if values of x and y are small, then we have seen that how to compute coefficient of correlation using this formula. So we will remember these two formulas and this method, step deviation method. Now if we want to find out RUV using this formula, here we will replace x by u and y by v, and we will obtain coefficient of correlation between u and v. Same thing here. If I want to compute correlation coefficient between u and v, I will replace x by u and y by v. So here I have written this all these things. Alternate formula for coefficient of correlation: rxy equal to n times sigma xy minus sigma x times sigma y square root of n times sigma x square minus sigma x whole square. This term is obtained by replacing y by x in this numerator, and this we obtain by replacing x by y in this term, n times sigma y square minus sigma y whole square. And if we give this number 1, formula 1 is useful if x bar and or y bar is not an integer, and if values of x and y are small. Correlation coefficient is independent of change of origin and scale. So as I discussed, suppose we are given x and y original variables, we define new variables u equal to x minus a over h, v equal to y minus b over k. Then correlation coefficient between new variables u, v, and correlation coefficient between original variables x, y is always same. And this we can compute, we can remember that formula. Suppose we want to use alternate formula, we will write this is equal to n times sigma uv minus sigma u times sigma v in the denominator square root of first term we write by replacing v by u in this numerator. So we obtain n times sigma u square minus sigma u whole square, and another term we write by replacing u by v in this term. So n times sigma v square minus sigma v whole square. So here we do this question using alternate formula, as well as we do this problem using the original formula which we were using so far. So we will discuss this question using this formula as well as the step deviation method with this formula. So I have solved this problem using both the formulas, and we find that answer is same in both the cases. It is given that psychological tests of intelligence and of engineering ability were applied to 10 students as per the following data. Find the coefficient of correlation. So here we are given the data for intelligence and engineering ability. So suppose we denote variable which denotes intelligence by x, and suppose engineering ability is denoted by y. So x and y are original variables, and this data is given for 10 students. That means we will consider n equal to 10. Now as usual, if we want to use that formula, original formula is this one. Then we have to compute x bar and y bar. After that we will find out deviations of x and y from their mean. After that we will prepare all these columns: x minus x bar, y minus y bar, square of x minus x bar, square of y minus y bar, and then we will find out total of each columns which are required, and substituting values in this formula we will obtain coefficient of correlation using that formula. So here is the table which we require. I have written all these values. This is the sum of x values. So this is sigma x, this is sigma y. Then we obtain deviations of x and y from x bar and y bar. So for that we calculate their mean first. X bar is sigma x by n, 990 divided by 10. So x bar is 99. Similarly y bar is sigma y by n, and it is 98. So x bar is 99, y bar is 98. So here we have to find out x bar is 99. So x minus 99, and this is x minus 98. So x minus 99 means we have to subtract 99 from each of these values, and we obtain all these deviations. Similarly, this is y minus 98. That means we have subtracted 98 from each of these values, and we obtain this column. This column is product of all these values. Then x minus x bar square means we are squaring all these values and writing here. Similarly, y minus y bar is obtained by taking square of all these values. So this is nothing but sigma x minus x bar times y minus y bar. This is sigma square of x minus x bar, and this is sigma y minus y bar whole square. So coefficient of correlation is Rxy equal to sigma x minus x bar times y minus y bar, that is 92, square root of sigma x minus x bar square times sigma y minus y bar square. So square root of 170, 140, and we obtain that coefficient of correlation between x and y is 0.596. Now we have done the same problem using step deviation method. For that we have to define two variables u and v. So we can consider here, we can see that gap between successive values are not same. Here gap is 105 and 104, so there is a gap of 1. Then 104 and 102, so gap of 2. Same thing here, gap is not common, so we will not take the change of scale. We consider only change of origin. So we consider u equal to x minus a and v equal to y minus b. Now this a and b is our choice. We can take any values of x and y as a and b, but we will consider that value which is in the middle of the data. So here I consider a equal to 100 and b equal to 95. So I define u equal to x minus 100, v equal to y minus 95. After that I will use this formula. Correlation coefficient between u and v is given by n times sigma uv minus sigma u times sigma v square root of n times sigma u square minus sigma u whole square and n times sigma v square minus sigma v whole square. So I will require product of u and v. I will require square of u. I will require square of v. So all these quantities I will require. I will require sigma u, so that I will obtain by taking sum of u values, then sigma v, sigma u square, sigma v square and sigma u into v. So from the formula itself you should decide that how many columns you will require in your table. So according to this I have prepared the table, and using that formula I have computed coefficient of correlation. So here I have written original values x and y, then u is x minus 100, v is y minus 95, then I multiply u and v. I take square of u, square of v. So for example, if I take x equal to 105 here, I will have 105 minus 100, that is 5. Then 104 minus 100, that is 4. If I take 100, I will obtain 0. So in this way I obtain these deviations of x values from assumed mean 100. Similarly, v is y minus 95. So if I take y equal to 101, 101 minus 95 is 6, and in this way I have obtained all these deviations. Sum of all these deviations turns out to be minus 10. Here sigma v becomes 30. Next column is multiplication of these deviations u and v. For example, 2 into 5 is 10. So you can easily calculate all this, and we obtain sigma uv equal to 62. This column is square of all these values, 5 square 25, 4 square 16. So in this way we obtain square of u values, after that square of v values, and we obtain sigma u square, sigma v square. So first we will prepare the table, and from table we will require all these values. So whatever columns are there, we will take total of values in each column. So now we have all these things which we require in the formula. So we substitute all those things in the formula of coefficient of correlation, and we have to write down systematically. Suppose we are using this method, step deviation method. So here I have written, we find coefficient of correlation by changing the variables x and y to new variables u and v, and we consider u equal to x minus 100, v equal to y minus 95. Now the coefficient of correlation between u and v is obtained using this formula. So we have all these values. N is 10, sigma uv is 62, that we have obtained from the table. Sigma uv is 62. Sigma u is minus 10, sigma v is 30. So sigma u is minus 10, sigma v is 30. Here also we put sigma u equal to minus 10 and sigma v equal to 30. Sigma u square and v square are 180, 230, n is 10. So this is easy, you just have to prepare the table, you have to find out all these summations, substitute in this ready-made formula, and after using scientific calculator I obtain this same value, 0.596. coefficient of correlation between U and V is 0.596, and we know that coefficient of correlation is independent of change of origin and scale also. Here we have used only change of origin. So Rxy must be equal to RUV, and RUV is 0.596. So we can compare using any of these two methods, we obtain the same value. Here we have used this formula, and we are not having any problem in using this formula also, because x bar and y bar are integer values and values of x and y are small. So it is comfortable to use this formula also. But I have done the same problem using step deviation method to explain the method. So this step deviation method is useful if values of x and y are very large. If they are very large, then this formula will be useful, provided we consider appropriate change of origin and scale. And if x and y are not integer, then it is advisable to use this formula. If x and y are not integer, then we will use this formula to compute coefficient of correlation. Either we are using step deviation method or we are using this original variables. But if x and y has mean which are not integer, then it is advisable to use this formula. If x bar and y bar are not integer, then we will use this formula. We can easily remember this. I have written it several times. Sigma x whole square, and in the product sigma y square minus sigma y whole square. So if x bar and y bar are not integers, and if values of x and y are small, then we will use this formula. If values of x and y are large, then we will use step deviation method. We will define new variables and we will try to minimize our calculations. So this is all about this session. I have explained that how to use different formulas for coefficient of correlation in different situations. So I hope you like it. Thank you very much.